there is this amazing trick that I like to follow for integrating the odd powers of sines and the cosines. What you do is whenever you see an odd power, just separate one term, sine or cosine, whatever it is, and write the remaining term. So for example, in this case, I will just write that sine cube as sine squared times sine. Okay, and this trick is really applicable to any odd power of sine or cosine. Okay, so that's such an amazing trick that you can use. Then what you do is for whatever the even power that you have, in this case I have sine square, just convert it in terms of cos. If it was cos, just convert it in terms of sine, just convert it into other way around. Okay, so what you can do is this sine square of this angle can be just written as 1 minus cos square 2x plus 1 by identity times sine of 2x plus 1 with respect to x. Because we know sine square theta plus cos square theta is 1. This sine square 2x plus 1 can just be written as 1 minus cos square 2x plus 1. Now, since you can see here that there is a sine term present along with that dx, if we put that cosine term as u, the derivative is present right here. Okay, so how that will help is just say that cosine of 2x plus 1, just put that is equal to u. And why do we do that? Because the derivative of cosine, which is minus sine, minus can be easily managed, but the sine term is already present in this integral. Okay, so what we can do now is differentiate both the sides with respect to x, because we'll need to convert this entire integral now from the x world to the u world. So derivative of cos with respect to x is minus sine 2x plus 1. Okay, and derivative of 2x plus 1 is 2 by chain rule. Okay, derivative of u with respect to x is du by dx. I hope that makes sense. If you notice here, we want sine 2x plus 1 times dx. And do we have that here? Yes, we do. Sine 2x plus 1 is over here, and the dx is over here. So what you can do is just multiply that dx on the left hand side, okay, and take that 2 on the right hand side, and also take that minus on the right hand side. So what we have, therefore, sine 2x plus 1 times dx is equal to, take that minus on the right hand side, so minus du divided by 2 on the denominator in the right hand side. So I have that sine term times dx is equal to minus du divided by 2. Now let's convert that entire integral from the x world to the u world. So we have integral of 1 minus, this cos term is nothing but u, so I have 1 minus u square, and this sine times dx is nothing but minus du divided by 2. I hope that makes sense. Such a simple integral it is now. Okay, you can just take that minus half, which is constant, out of the integral. So you have minus 1 by 2 integral of 1 minus u square with respect to u. Now just give that integral to both of the terms. So we have minus half, let's put a bracket. Integral of 1 with respect to u is nothing but u. Integral of u square with respect to u is u cube divided by 3, plus let's add the constant of integration c, and that's your really the final result. You just need to convert it now back to the x world. U was cos 2x plus 1, so you can just substitute the value of u. So you have minus half cos 2x plus 1 minus, and this u cube will become cos cube 2x plus 1 divided by 3, close the bracket, the constant of integration c, and this is your final result in the x form. I hope that makes sense. If you like the concepts that I'm teaching you, please do consider to like this video and subscribe to this channel. I do post calculus and math content every single day. That's another reason to subscribe. I'll see you tomorrow.